Ever wondered how the concept of existence is treated in the vast fields of logic and mathematics? Let's take a moment to ponder on this, shall we? You see, existence as a concept is something we often take for granted. We exist. Our thoughts exist. The world around us exists. But what does it really mean to exist? In our day-to-day lives, existence is often linked to physical presence or subjective experience. However, when we venture into the realms of logic and mathematics, the idea of existence takes on a different hue. In these fields, existence is not simply about being tangible or perceivable. Logic and mathematics are abstract by nature. They are not bound by our physical world, but rather they construct their own world of ideas and concepts. Here, existence is about being definable within a certain system, about being a part of the grand scheme of things. Let's delve a bit deeper. In the world of logic, particularly in predicate logic, we encounter something known as existential quantifiers. Now, that's a mouthful, isn't it? Existential quantifiers are symbols used to express that there is at least one thing in the universe of discourse that satisfies a given condition. In other words, they give us a way to talk about existence within the framework of logic. In mathematics, the concept of existence becomes even more abstract. Mathematical entities like numbers or geometric shapes exist, not because they have physical form, but because they are definable and consistent within the mathematical system. They exist insofar as they can be logically derived from the axioms of the system. So existence in these fields is less about being and more about being definable, being consistent, being a part of the system. It's about being able to say, yes, this is something that can exist within the rules and boundaries we've set. So, as you can see, existence in logic and mathematics is a whole different ballgame compared to our everyday understanding of the term. Now, what are these existential quantifiers we just mentioned, and how do they function in predicate logic? You might ask. Well, let's dive in. Existential quantifiers are essentially the symbols or terms used in predicate logic to express existence. In a nutshell, they say that there exists some object or entity that satisfies a particular condition. The symbol for an existential quantifier is usually a backwards E for exists. Imagine, if you will, a grand library with countless books on its shelves. You're searching for a particular book, say a novel by a certain author. In the language of predicate logic, this could be expressed using an existential quantifier. There exists a book in the library such that the author of the book is the one you're looking for. Here, the existential quantifier is the phrase, there exists a book. It's stating that there is at least one book in the library that fulfills the condition, that its author is the one you're seeking. But the beauty of existential quantifiers doesn't stop there. They can also be used in more complex logical statements. For instance, you could use an existential quantifier to express the statement, for any author there exists a book in the library such that the author of the book is that author. This means that for every author you can think of, there's at least one book by that author in the library. So, existential quantifiers are quite versatile. They allow us to make sense of complex logical statements and to express the concept of existence in a precise and rigorous way. Whether we're talking about books in a library, stars in the sky, or any other set of entities, existential quantifiers help us articulate the idea that there is something which satisfies a certain condition. In other words, existential quantifiers are the tools that predicate logic uses to express the concept of existence. They're a fundamental part of how we understand and communicate about the world in a logical and systematic way. Moving on to mathematics, how does this field approach the concept of existence? Well, it's fascinatingly different from our everyday understanding. In the realm of numbers and equations, existence takes on a unique twist. It's not about seeing or touching, but about proving. Consider the task of solving a puzzle. Before you even begin, you'd probably want to know, does a solution exist? In the same way, mathematicians often need to prove that a solution or a certain mathematical object can exist without necessarily finding or constructing it. This process is known as an existence proof. Let's delve a little deeper into this. Imagine a jigsaw puzzle with hundreds of pieces. You don't know if all the pieces belong to the same puzzle, or if some pieces are missing. How would you approach this? Would you start connecting pieces hoping it will form a coherent picture? Or would you first want to establish that a complete picture can be formed with the given pieces? This is where the concept of existence in mathematics comes in. Instead of immediately trying to solve the puzzle, mathematicians would first establish the possibility of a solution, proving that a complete picture can exist. And this proof of existence is a crucial first step. It's like a treasure hunt. Before embarking on the arduous journey, you'd want to know if there's indeed a treasure out there. Digging up the treasure is a different challenge altogether. Similarly, in mathematics, proving the existence of a solution can be distinct from actually finding the solution. True, it might seem counterintuitive. In our daily lives, we often equate existence with tangibility. If we can see it, touch it, or interact with it, we say it exists. But in mathematics, existence is a matter of logical possibility, a question of can it be rather than where is it? So in mathematics, proving the existence of a solution can be as important as finding the solution itself. Why is it important to understand the concept of existence in logic and mathematics? That's the million-dollar question, isn't it? Well, let's dive in and explore together. Understanding existence in logic and mathematics is akin to holding a compass in uncharted territory. It gives us direction, helps us navigate complex problems, and ultimately leads us to solutions we might not have otherwise found. Let's consider logic for a moment. When we understand existence in this realm, we're better equipped to reason and make sense of abstract concepts. We can draw more accurate conclusions and build stronger arguments. Indeed, the existential quantifiers we've discussed earlier play a key role in this process, allowing us to express complex ideas succinctly and efficiently. In essence, they're the tools that help us to cut through the noise and get to the heart of the matter. Similarly, in the world of mathematics, understanding existence is like holding the key to a treasure chest of problem-solving strategies. It allows us to prove and disprove theories, to manipulate equations, to unlock the secrets of the universe itself. From the simple arithmetic we learn in school to the complex equations that underpin scientific discoveries, existence is a fundamental concept that underlies it all. But more than that, understanding existence enhances our ability to use these disciplines effectively. It's not just about solving problems or making abstract concepts easier to grasp. It's about expanding our minds, pushing the boundaries of what we think we know, and opening up new ways of thinking. It's about challenging ourselves, questioning our assumptions, and striving for a deeper understanding of the world around us. In the grand scheme of things, understanding existence in logic and mathematics is a stepping stone towards a greater understanding of the universe and our place within it. It's a journey of discovery, of curiosity, and of infinite possibilities. In essence, understanding existence in logic and mathematics can open up new ways of thinking, reasoning, and problem-solving. So let's keep exploring, keep questioning, and keep pushing the boundaries of our understanding. Because in the end, isn't that what it's all about? Let's take a moment to recap the key points we've discussed today. We've unpacked the role of existential quantifiers in predicate logic, where they signify the existence of at least one element satisfying a proposition. We've also delved into the concept of existence proofs in mathematics, demonstrating a mathematical object's existence without necessarily providing an explicit example. Finally, we've underscored the importance of understanding existence as it's pivotal in the realms of logic and mathematics. So the next time you think about existence, remember that it's not just a philosophical question. It's a crucial concept in logic and mathematics too.